This is the first video in the derivation of trigonometrical formula for the Irish course at Leaving Cert level. Now, when you're doing the derivation of formula, the important thing to remember is that you can use stuff that has been proved or has been used before. And the idea is that you do not learn this proof. What you do, or derivation, what you do is you learn a key line in it. And what we're going to do today is we're going to use the formula which is called the distance between 2 points formula. And that's all you need to learn in order to derive cos squared plus sine squared is equal to 1. So d, the distance between 2 points, is the square root of, and it's in your formula book, so you don't even have to remember it. It's under coordinate geometry. And it's the distance between 2 points, and it's x2 minus x1 all squared. Plus y2 minus y1 all squared. I said square rooted. So it's the square root of x2 minus x1 all squared, y2 minus y1 all squared. And all we've got to do is basically use the information on the unit circle, which is also given in the formula book. So you can draw the unit circle from the formula book, and you can quote the formula for the distance between 2 points in coordinate geometry. So essentially, there is nothing to learn for this particular derivation, because all the information you need is in the formula book. Okay, you have to remember to start off by using the distance between 2 points formula. So let's go. What do we know about this position here? Well, we know this position here has a coordinate 0, 0. We know the distance in between is equal to 1. So we now know that the distance is equal to 1. One set of coordinates is 0, 0, which we are going to label x1 and y1. And the other set of coordinates is up here, which we're going to label x2 and y2. And then we're going to just substitute it into our first line. So 1 is equal to the square root of open bracket x2, read from your diagram, is cos A minus 0, all to be squared, plus open bracket y2 is sine A minus, well, y1 is equal to 0, all to be squared. Tidy up line, 1 is equal to, well, cos minus 0 is just cos, so we got cos A, now all squared, plus bracket sine A, all squared, with a square root symbol around it. Now we're going to basically just square both sides in order to get rid of the square root. Now I just want to remind you, it's a slight abuse of notation, but it's accepted. Cos A all squared, we are allowed to write that as cos squared A. And sine A all squared can be written as sine squared A. It just means that we don't have to write brackets, but we know what it means. Now what we're going to do is, clearly, to get rid of the square root, we're going to square both sides, and then we'll finish off where 1 squared is 1. The square gets rid of the square root, so we end up with the result, and it's all very neat. It's all very easy. And all we used in order to prove this is the picture from the formula book on page 13 of the unit circle, and the distance formula, which I'm asterisking now to draw your attention to it, which is on page 18 of the formula book. So very, very simple. Now we're going to go on to proving formula 2. And we're going to use a very simple process for this. We're going to use a formula which is already been pre-proved. And the formula we're going to use is we're going to use the area of a triangle is equal to 1/2. Now, I would actually remind you, if you can't remember what the formula is, you do know that the area triangle formula is in your formula books, it's in trigonometry, it's also in the area section. You really can't get this wrong, but it's 1/2 AB sine C according to the formula book. Now, what you've got to remember is it's a relational formula. We can start off with it by using what they've used in the formula, which is basically the angle C. And so therefore, using this formula, I know that the area is equal to what it is above. However, so that's actually done. That first one is done. But we're going to work out an area in a different way. And what we're going to do now is we're going to work out the area for this angle. And as I said to you, the formula above is a relational formula. So what we have now is, what does the relational formula mean? Well, it's half. Now what you have to have is you have an angle and two sides spanning it. So if you've got two sides and the included angle, then this is how you use this formula. So therefore, do I have two sides? Yes. What are those two sides? They are C and they are B. What is the angle in between those two sides? It is the angle A. So we've now got sine of the angle A. I can do it a third time. I can work out the area a third way. So once again, I've done the circle, so I've clustered my three pieces of information together. I have now got two sides and the included angle again. So the area is going to be, well, half the two sides, which are A and C, and the sine of the angle in between them, which is the sine of the angle B. Now, the great thing about this method is it's the same triangle. It hasn't changed, which means the area, no matter which formula I use, must be the same area. So I can pick two of my equations, and what I'm going to pick is I'm going to pick 2 and 3, and I know, because it's the same triangle, that both areas are equal. So since area is preserved, I can now write down, therefore, 1/2 of CB sine A must be equal to 1/2 of AC sine B. I can then move this on by cancelling the 2's on both sides. So I'm going to cancel the 2. Do it in pencil so the examiner still sees the original. I can cancel the C's on both sides, and I can go to a rewrite line. And the rewrite line is B sine A is equal to A sine B. And this is where it does get very, very simple. Because according to the question, we've got A over sine A. So the letter A should have a sine A underneath it, according to what we're trying to prove. So I'm going to put a sine A under the A. But if I put a sine A under the right-hand side, I've got to put a sine A under the left-hand side to keep the equation balanced. I'm also looking now here, and it says B over sine B. So this B should have a sine B underneath it. So now I put a sine B under the B, but whatever I do to the left-hand side, I must also do to the right-hand side. So once again, getting a light pencil out, clearly the sine A is going to cancel with the sine A. The sine B is going to cancel with the sine B. And what we're left with is B over sine B is equal to A over sine A. and we have proved the first two. We have proved the first two. Now what we do is, the great thing about mathematics is we say similarly. We don't have to go through the same process again. We can say similarly, b over sine b will be equal to c over sine c. Therefore, proof follows. And we have finished. Now, once again, what is that based on? Remembering one key fact, using the trigonometric version of the area of a triangle, and that the area, no matter how you work it out on a given triangle, is preserved. Okay, we're now going on to formula number 3. And formula number 3 is the cosine rule. Right, the bad news, and it is bad news, is this diagram is not drawn. So the first thing you've got to do is learn this diagram. Once you've learnt this diagram, then the next thing you've got to learn is the actual method. And the method is very, very, very straightforward, because it's also using the distance equation. So we're going to be using the distance equation again. Let's just remind you, that's the distance equation in the coordinate geometry section of your formula books. And that distance equation is on page 18. And the distance between 2 points is the square root, open bracket, of x2 minus x1, all to be squared, plus y2 minus y1, all to be squared. Okay, easy enough. You have got to learn this diagram. We know from what we've done with unit circle that if this is a length 1, then the coordinates are going to be cos A and sine A. But you've now got to remember that if that's length B, then the coordinates will be b cos A and b sine A. So if you do not learn this diagram, you cannot do this question. So that's your homework. Learn the diagram. When you do a test on this, and you will do a test on this, make sure you get this diagram right. Now, what people muck up on is we've given the 3 lengths of the triangle as you will find them in the formula book, A, B, and C. So this length C here is the full length of the triangle. So how far is it along from the origin? Well, it's a distance C from the origin. How far up above the x-axis is this point? Well, it isn't. It's on the x-axis. So therefore, because of that, because it's on the x-axis and C along, I can establish a coordinate for it. And that coordinate is C0. Okay, so now I'm going to call this x2, y2. I'm going to call this x1, y1. And clearly, the distance between these 2 points is in actual fact A. The distance between these 2 points is A. So let's start our process. A equals the square root. Well, do you know what? Just to make our lives just a little bit more easy, I'm actually going to change this formula, and I'm going to square both sides straight away. So I don't have to keep writing out the square root symbol. So now d squared is equal to, open bracket, x2 minus x1 all squared, plus y2 minus y1 all squared. Now I'm going to sub in the information. I know d is the distance between the 2 points, and from the diagram, just remind you here once again, that the distance between these 2 points is a. So that's now a squared. A squared is equal to x2. What's x2? Well, that's b cos a. minus x1, which is c, all to be squared, plus y2. y2 is b sine a. b sine a, so there's b sine a there, minus 0, all to be squared. So we now need to square out these brackets. So a squared is equal to b cos a minus c on b cos a minus c plus b sine a all squared. So when we square out these brackets, b cos a on b cos a is going to be b squared, cos on cos, cos squared a. B on minus c is minus b cos a on c. And then we've got minus c on b cos a again, so that means we have two of them. And then we've got minus on a minus is a plus, c on c is c squared. Plus, well, we've got b sine a all squared, which means the b is squared and the sine is squared, so it's b squared sine squared a. And we keep moving. So now we've got a squared is equal to put patterns in. That says b cos squared a. And I've noticed at the end here is plus b squared sine squared a. So I'm going to put them next to each other because, quite frankly, it seems like a nice fit. I've also got plus c squared. And so I've done that. Why have I done that next? Well, do you know what? I took a sneaky look at the formula. And I've also, hang on a minute, there's a b squared at the front. So that's another reason for putting the b squareds at the front. The b squareds at the front here, and guess what I've done? I brought the b squareds right to the front. What comes next? C squared. So I brought the c squared next. So using the formula is very handy. Using the formula you're trying to prove as a guide rail is a very, very good idea. Oh, look, we've got 2b and there's a c. So I'm going to bring the c up to the b. So 2bc and then it's cos a. So I'm just rewriting it as I go. 2bc cos a. And guess what? That's exactly what it's at the top. And then we've just proved something. Formula number 1. So I'm going to take out b squared as a common factor. And if I take out b squared as a common factor, why am I doing that? Because the question only had a b squared. How do you isolate an item when it appears more than once? You factorize it. So taking out the b squared as a common factor, you now got b squared on the outside of cos squared a plus sine squared a. Hang on a minute. Maybe only 10 minutes ago. What did we prove? We proved that cos squared plus sine squared is equal to 1. So the next line is a squared is b squared on 1. We've already proved that. And now we've got a squared is equal to b squared on 1, which is b squared, plus c squared minus 2bc cos of the angle A. Have we proved it? Yes, we have. Derivation over.